Yeah, so outbound API itself do not do any actual algorithms or logic. It depends on the backend, the bundle function. As you can see here, the outbound bundle depends on the topology manager right here. Okay? Which is the base topology manager, which we wrote in the base infrastructure. Okay? So one thing you can see here is there are two ways to get the same dependencies. One is if you define the activator and do a set callback, you're going to get a callback for dependent bundle. We showed you the dependency on how to activate the dependency and how to do the set callback to call the appropriate bundle and the differences. Other way to do it is this way. If you do it this way, right? You do a service developer and get this dependency, you can go and get any container bundle and you can start playing with that. The only difference between the way of getting the reference from here and the activator is that if you put the dependency on the activator, if the dependency is not resolved, your bundle is not even come up. Your bundle will be in stall state. But if you don't use the activator and then use it by a service developer from here, then your bundle will be alive even though your dependent bundle is down. Yeah. Right? So say for example, topology manager, somebody stopped. Okay. If somebody when stopped, routing manager will stop also. They're completely dependent. The activator level is completely fused one. But here, topology outbound is not completely dependent on that because it's not defined in activator. Rather, at every API call, we are requesting for the dependency. So that's the difference. Okay. So you can potentially get the reference from any point using this.
So it's not dependent because you didn't specify that you didn't want to be dependent.
Correct. I don't want to make it.
Okay, so in theory, you got dependent upon narrative because
correct.
It requires it.
Correct. Yes.
Okay, so you just want to be able to return an error or something.
Yeah, just return an error. So somebody says null is not potential.
Yeah.
Right. So in an OGI bundle, anybody can go. So that's the thing, right? You cannot assume any reference is alive at any point of time. You cannot assume that. Okay? So what is null? You return null. But if you fuse the dependency using activator, your guarantee is that your bundle will have null because it's not even come up. Right? That's the difference. So you see different code, different places where some people will choose to have not depending completely on that. Right? And even if you choose the dependency on the activator, you can say it's required or optional. You can say that as well. Because there are various ways to tweak the dependency on the OS.
Yeah? Sure, and then the assumption is that this is still running basically the same behavior. So this is your topology manager, everything. So there's no communication between that. There's no way that this is going to be separated from the first that's here versus something else that's going to be sort of topology manager. Like your topology is running the same basically the same JVM.
Correct.
Is that going to be an issue in terms of scalability, or is that just the assumption that that's always going to be basically everything in a separate silo?
Okay.
Because you're basically your for mid-tier might have different requirements in terms of scalability and processing from your left tier that is serving end user request per second versus your middleware that's going to be that scale for different.
Okay, excellent point. I'll now jump into this topic of clustering. Okay? The controller, we have a concept of clustering in place. It's not working, we're making it work, we're making it. It was working before we broke it, we're making it now. Right? Always working. The concept of clustering is actually simple. We can spawn multiple controller instances, right? In various servers, different regions, right? And we use a protocol called infinity span. Infinity span is a JGroup span. If you guys read the discussion going on in the email threads, you see that infinity span is being discussed many times, right? You know the discussion, right? Consistent and instruction, right? We have infinity span in place. Infinity span is not completely dependent on we have a clustering service which is internally. What does infinity span is based on JGroups? When you think of the controller in a clustered mode, all these controllers sync up the groups. Yeah. Today we have a replicated mode where every controller sees what are the complete.
That's why JGroups.
Where the JGroups is the base,
yeah.
infinity span is the
So you use the infinite span
Use
practice to synchronize it.
Correct. Yeah. Jacobs is very low level.
Yeah.
Infinite span is this is very easy to use. If you get interested in infinite span code, the code that you use, you look at this clustering services implementation right here, right? It does all the transactions and all this. So, say this is the case. We use infinite span to sync the distributions. Okay. Sure. Now, applications that is sitting on top, okay, they can, there's no dependency for them to talk to one another. They talk to any other because the states are synchronized. So the approach that we are taking now is on southbound, we are talking about the active active controls. Like all controls are active at the same time. So now let's take open for example. Say we have 100 switches. Okay. Now on the switches, you can have say 25 of them connect to this one. Other 25 connect here. Like in open for 1.0, you can have active standing only. Or 1.3 you can have active active. So it doesn't matter. So from the control standpoint, we are active active one. So at any point of time, we can scale the controller southbound and northbound based on number of customers. So an application is any of top, right? It has a requirement of million packets or million instruction per second. Of course, one controller cannot handle the load, right? So we can have a SP load balancer, right? So it can be load balancer, which has a virtual IP and a physical IP now. Virtual IP can take this request and start training to the controllers. It can, right? Since the states are synchronized always, you are guaranteed that you can scale horizontally by adding more controllers, not for horizontal. Yeah. There are two kind of mechanisms that you're talking about. You're talking about state synchronization and event synchronization. Okay? So there are mechanisms. Mostly you have to use the state synchronization mostly. Okay? Use event sync, then the performance will tank. Okay? So in most scenarios, you go with state synchronization where any controller that gets the event, right, it writes the database, and database gets synced. The rate database that comes in not like a this rate effect. In those cases, you do even involve. But even things it should not be used like for all. This is not okay. It will also be across. Also, usually for event thing and staging, event thing is again you have a boolean, right? This will say this is in the state, so become an event themselves. Even though it's event thing, again state thing, but it's going to trigger the event on the other side. So every controller in a state is thing, every controller will get a callback. Everyone say, hey, your state is thing, you want to access anything with you can design on that. You can decide not to do that. On event in case you will go back and say, hey, I want to add this event and no, have different policy on the yeah, put it this one, right? Yeah, so now property manager is going to run on every control, right? So run on every one. So this being null is the only case can happen only when you have you have brought down the bundle on a given controller, right? So from our standpoint, since the same control is running everywhere, you can property manager. This running locally or not is not the problem. The real problem is how are you going to scale for application needs? That you want to scale using cluster. And if you look at the code, right? I will point to the code where the clustering code I showed you. They'll make it even more solid. It's good topology manager. Sorry, I'm jumping, but it's not organized pieces. It's okay to talk about this. Good topology manager, you invariably see many data sets are called or concurrent map. Even though we could have used a list, array list, we could have used anything else, we would have used concurrent map. Okay? The only reason is because the infinite span right? Infinity span can synchronize only concurrent maps. Okay? Right? Very important note here. Infinity span is a transparent distribution mechanism where if you have a concurrent map, right, and represent it as saying, hey, I want to see a concurrent map for my database, distributed database, then infinity span takes care of it transparently for you. So now there is a concurrent map, you can be rest assured rather than use infinity span. Most likely. Okay. So let's go and see how we create this these objects. Okay. Let's look at node connected DB. There you go. See, look at here. We create the node connected DB. Okay. Using container specific service. We're not saying node connected DB equals a new concurrent hash map of this one. We're not saying this, right? All we're saying is, hey, I want to create a cache called property manager and node connected DB, right? I want it to be non-transactional. Hey, sir, customer container, please create it for me, right? So what it says is, it actually goes to infinity span code base. Infinity span says, okay, I want to create, you want a cache to be created. You create the cache with the name property manager node connection DB, and give you back a concurrent hash map. Now, how do you use the hash map? You just go and say dot put or dot get, right? Just say dot put. That dot put call will get converted into a custom synchronization. So let's look at the code. Let's put node connected DB dot put, right? Setting a put here. It looks very very simple, right? They are just putting to a local DB. Actually, it's a remote. When you do a put, it's actually synchronized across transparently. So one thing you do is you create the cluster DB, and then rest is assured synchronized. So there are a lot of discussion going on. Yes. 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 Correct. It depends on the various configuration available in this plan. You can have replicated mode also. Replicated mode is where you replicate everywhere. Okay. So you have to assume this, right? Depending on where you place the customers. If there is place one controller here, one controller in India, you expect a lot of speed. So it really depends on various mechanisms to see the performance of the system. Yeah. And then this is this one. My handwriting sucks, so I'm not sure. Yeah, this is the infinite method mechanism. This is a JBoss project. This is JBoots as the handling mechanism to synchronize the states. Infinite. So there are various mechanisms. We also the Pixel space are using Cassandra are doing this. Cassandra cannot do consistency in the protocol in the database. It has to do with consistency. So, but we mean the Cisco when we wrote this code, right? One primary actually we had was the application should not worry about synchronization and consistency. Application should assume that hey, I program some stuff. The implementation takes care of computer across. So the operator must get a guarantee from the controller stating you always get a consistent view on all. It's not available. That's the objective that we get. But there is a problem where it's a KPM where you cannot get consistency, availability, and function from the station. You cannot get it. Right? So it's really it's a distributed response, right? How each application want what and what kind of. It's still going on still, but yeah, now we are coming to some kind of consensus on how to approach it. So for now, they will use this plan as approach, but discussion is happening. Yes. Not in this plan. Because business plan by default, right? It is in memory by default. Okay. But there is various plugins which we can enhance it. But at this point, look at the controller today. Here, it is in memory. At this point.
your VM crashing, so your assumption is that it's the multiple, like these instances of infinite, like what if that's big memory, so that VM or wherever that infinite method crashes. Sure. I mean, so the assumption is that you have to have at least one more instance.
Yes, that's fine. And that's right. See, if you have such an database, right, then it's bound by persistent storage. You have centralized storage, and you worried about what if centralized storage crashes and all of this. Right? So you kept it very simple. The entire idea of this control, right, even though the initial setting the process on the OSD side, but all the principles are simplicity is key. Although we want to keep it simple, and we want to see how it goes, and then we want to enhance it. We don't want to over architecture.
You're right, but crash maybe was because it's kind of a problem state. We back up with the state from the underlying level. But on the other hand, obviously all of the things that means we are obviously someone
See, to be clear, right? We still have consistency, right? We still have the consistent storage, but not at the database information level. Today we have a game, we have used stack file. So whatever configuration policy is right? Those are saved today in the file system. Today what do we serialize the objects to files? To do what we don't synchronize at that storage. Right? For example, Copilot, this is file network. Okay? We don't save it in data. It's runtime on the memory, it's synchronized, and as we control goes to it goes away. So what is consistent? What is consistent is the configuration by the policy one example.
But then you still need to somehow synchronize that part.
Yes.
That is no, but that right now is synchronized.
Which one?
It's data configuration.
What is synchronized?
It's synchronized. What's up with the
Yes. Synchronized too. Yes. And the policy saving part, right? Look at the code. You see an example of even for saving the policies. Even though we synchronize the policy configuration, and the user hits the save button. You hit the save button not everywhere. Right?
Files that get copied in multiple ones, or when you say that basically backed up by infinite time on that particular instance.
Infinite time is involved in the consistent storage there. The local state is that if you use the file system, the storage locally.
So how do you synchronize that? Or how do you synchronize that across multiple functions? Do you synchronize that across? Like did you say that policy, like if you write policy file?
Policy synchronized.
Okay, so how do you synchronize that? Like, do you send that
Using
event?
the cache. Same cache.
Okay, so then these guys are going to get an event and they're going to support the local.
Only for saving to the local file system, use event. See, it's an event. Storing it to the local file system is an event. We cannot do a cache to make it happen. We even think of that. But all the states are synchronized by cache.
And it seems like we have, like, how long did it take if you take one of these and just kind of down and then bring it back? Like, what is sort of like how long, depending on here, I assume it depends on what you have in memory, but how long did it take to get it up to sleep, or do you have to put it right and then get over it?
Oh, no. This is all into the way. Okay. So, let's just do an example. Right? I always run with 4 clusters, but mine is not a right way to approach it because mine is 4 VMs running on the same ESX server, right? So it's not the right thing that you have to do that. But in my case, right, what I have seen is the clustering has to understand there's one is what on. They have a heartbeat mechanism on the groups. The heartbeat is of course speakable. You can have a very aggressive heartbeat or have a relaxed heartbeat. By default, no change that we made. I have seen in 3 seconds, otherwise the radius 1% has gone down, and they automatically start adjusting their source model. It takes 2 seconds.
And then it's bring it back up. Like,
bring it back up is not a performance thing, right?
but in terms of the process, they just so how it's like things up, you just bring it up.
Oh, that's all right. So when you bring up, right, there are
So how does it know? So I bring
not objective. Okay, the controller will not be beamed up until the state is synchronized. That's why we are stating in default. Right? So only after everything is synchronized, we'll open up the alternate API. So we have the code of it. However, it will be not even be up. So we set up. Yeah. You touch on the nerves, right? So the cap is a captain or something. So what you have a partition? The problem. See, it's a partition, right? Of course, you cannot synchronize space. Now, say you have a partition here, right? This one. That means you have a local consent. You have consent in these two and in these two, but not the not the students. Right? So that's exactly what's happening. You read all the emails that's happening on the forum. It's exactly on the stop, right? What's happened is it goes away. These two will be synchronized. This will be synchronized individually. Yeah. Then eventually they come back up. Right? Not today we don't recover. Yes, and that's all the switches. It cannot happen, right? See, for example, if this state is updated here, it can happen only these switches. And of course, this may do it here, but these states cannot. They are not functional. Um, see, then the partition happens. So the partition happens, right? If the application is also going to manage the partition happens. The application is also going to respond. With this cap here, the second word possible. We cannot provide consistency and the partition all the same time. So you are designing a system using the virtual consistency model. What consistency model is nothing but application must manage your consistency. It's not the issue of the controller to manage the consistency. Right? That's it. Virtual consistency is exactly that where is a problem, right? There's no consistency. Eventually, eventually. Eventually is moving target, right? So since you cannot have moving target, application has to manage efficiency. That's the underlying principle behind it. That's the discussion happening. Very bad discussion going on now. Still going on. It's not a big deal. Still going on. One of the longest surveying credits that. We don't have an answer yet. No answer yet. Please contribute if you have a solution here. We don't have an answer. Protocols. Okay. Okay, let's go there. I'm not going to the submode yet. I'm coming from top. So this OSJ northbound, they're going down. Yeah. Yeah. So, see, okay, so one thing is the controller today, we don't even have today like common infrastructure for configuration management. We don't even have it. Right? So first of all, we are trying to have a customer service, right? We did something interesting there. Customer service, we made it a service, right? And infinite span is under that. So infinite span goes away, consider a constant, doesn't matter, application will not change it now. But for the persistent approach today, every model is doing its own persistent approach. First, you have to remove that. First, you have to make it a configuration service. It does whatever it does. It could be a file consistency, persistence, or database persistence. Right? It's we haven't really thought about it. Okay, that's a fair. Okay, this database is not the ephemeral streams. It's the configuration stream. Yeah, very different. Very different. That's no way. Once you have a configuration service in place, then who's going to implement what? For example, right, the controller, that OpenDaylight controller might just have the configuration implementation, might just have the files stored. But maybe you have a controller, right? Take OpenDaylight controller, and you can plug in your own configuration implementation. That cannot remove the implementation that is OpenDaylight. Right? You can have database. So you're not going to stop anybody developing a new implementation. That's proprietary way of doing it. That's why each of us can dial right to the controller. So first thing we'll do is introduce a configuration service. That's the first important piece of it. Yeah. So we use different strategy, of course, to synchronize the language skills. So topology is a good example. Right? Topology is FMS. Right? Topology will keep changing, it's very dynamic in nature. Correct. Host coming up, host going down, the VMs. Correct. Infinite. Correct. Infinite span is just okay. It will. It will. So there is no partition, for example. Topology is always constrained. Eventually, not eventually, I don't even get it's always constrained. The partition is the problem. That's the question that we asked. What is this partition? That's how the problem starts. That's where the big discussion happens. Which I don't have an answer. No, the question is, what is happening? So application has to convert. Sorry, man. Like what I say, like I expect somebody I'll be interested to know. Yeah. So what is the basic one? Right? You are taking yeah. See, thing is,
See, I'm not doing what that also. That would do and it is like so as far as that would be like because all the sorry the application even if it is then you open it to understand here so you get any kind of this is a new thing. If you are new thing, then you are having a good so it is immediate. So I don't think you are here and create because the application is responsible for I doing that regularly. Like and but if the repeatability is not met, then you have a problem that you are trying to solve. Then because you are skillful, you are not skillful.
Control the shit food. Control the hot shit food. You like it or not?
And that makes this controller stay put.
Not this controller, any controller.
I believe I don't know.
Okay, guys. I think we went way too off tangent from where we are. We are discussing about not only APIs and we went all the way to distributed computing. Yeah, I don't know where I left. So I had to change that. Okay, now I know. Yeah. All right, we are here, right? Now, someone else want we use the service helper to get the policy measure, and this being null or not is it's not a question of scale or performance. Scale performance comes into the clustering approach. Here, it is null, that means it's not there. So yeah, good. We also touched upon the clustering, so I can skip that and move for next target stuff. So all the northbounds are, as I explained, right? Every northbound API is going to look exactly the same as I explained now. So you can look at all the northbound APIs exactly the same. Similarly, look at the web modules. .web is in web folder. The web modules are all the UI. What are UI you see in the OpenDaylight? It's all the web modules. Okay? I'm not an expert in talking about that, so I cannot answer. So it's okay. Now let's look at the components that I mean. Okay, I will. Thanks. Uh, okay, man. I don't have. Yes, thanks. Um, yeah. Now let's go into the individual bundles, right? As I was explaining before, we actually the morning session we saw the pro programmer and how individual bundle is built. No difference, right? Exactly what we want to talk about here. But instead of touching the topic on how the bundle is built, let's touch the topic on what are all the base bundles that we say is the heart of the system. And I'll explain each bundle what it does, so that when you want to write an application, you can know which bundle to approach. Okay? So R bundle is straightforward, right? It's going to handle R packets. So it's going to handle R, it's going to assist the host tracker to say where the host belongs to, and it's going to take care of all the proxy RPing and all those things in the control center. It's there's no it's straightforward. There's no magic here. And if you look at the bundle structure as such, it's exactly the backend bundle discussion model. No difference. There's no not-bound API, something like that. It's purely based on activator that will define the dependencies and services. That's all the way. Clustering services, what we discussed so far, this provides the clustering mechanism for the database to be synchronized across the controllers. Use infinite span as the base. The clustering services is the API bundle, which has no infinite span knowledge, but only the implementation here as the infinite span. If you want to change it to a different implementation, you can do that. That's right. Right? So this one. Configuration is the state configuration. You do a configuration like policy configuration or a configure name of a given device. All the partition configuration are all through the configuration bundles here. Okay. The container manager. Okay. We discussed about this in length in the morning. Container manager is the one which actually is the global component which actually creates containers. Okay. This is the one. This is the one which is not belonging to a global container or any container. This is outside the container. This is the one. Okay. The implementation here is very lame. It's a basic implementation. We can replace it with a better implementation. Okay, it's not done yet. It's one way of approaching things, right? So when there's a need to have folks say, hey, I cannot have multiple sites in the same address space. Right? You want different address space. One way to solve the problem is that, hey, OSGI JVM is not running only one part. We cannot have, okay? And we don't want to run a remote OSGI configuration. Rather, one of the approaches we are thinking is we have a solution, right? We can have individual instances of the controller handling individual sites. That's the customer container. Customer will get a view of separate. Each container tenant is part of separate address space. There's a guarantee. At the same time, they get the benefit of central management. Right? So they are custom model. Now, managed decentralized. So from an opinion standpoint, they will not know whether it is running in the same controller. From a deployment standpoint, they can be guaranteed that they are isolated. It's an idea. Right? It's possible. There's an infrastructure available today, both clustering and containers. It's up to us to make use of it. The code is not there yet. They can contribute this topic. We contribute and write code. But it's all available. The pieces are there. You put the pieces together.
So right now you mean
right now, as it is, right? Everything is exactly the same. Right now, it's a replicated mode. Everything is the same. That's how it's done today.
But the conversation is saying that there will be some states inside of the anywhere because they
yes.
And those states will also need to be supervised.
So that's different.
Using infinite span.
Yes. Infinite span or whatever, right? That doesn't matter. Let it cluster and make it. There's no choice. Okay.
I think that would be touching relating with the partition, right? So probably when you want to talk about partition, those are the states of the net, which kind of okay because we have votes. When we power from partition, we can that partition. But if that's the states of the container itself, it's information right here. Then you can companies. Then that's the
See, there's no difference between the previous example here. Again, who is going to manage this content? There should be some organization. Somebody there, right? If there is a partition, then application is going to manage it. This is that happens. Exactly the same discussion. There's no difference between container now pinned to a given customer or not. Doesn't matter. Same discussion. Whether they state is state. Right? Then we have the forwarding rules manager. The forwarding rules manager is the component where we won't do any programming. Right? You won't do any flow programming on this agent. You have to use the forwarding rules manager. Right? So if you look at all the open flow mechanisms that we have today, portable forward programming, various. In fact, people are working on extensions now. So open flow extensions and Cisco, we are writing Cisco extensions for the vendor specific ones. Others also writing vendor extensions. All those programming aspects are done via ProProgrammer, the forwarding messenger. The ProProgrammer app is running on top. Is basically essentially uses the forwarding rules manager and programming steps. Okay. Forwarding static routing is a mechanism that we wrote here to provide some kind of a bridging between OpenFlow and non-OpenFlow networks. Say I have an OpenFlow island, right? And I want to send traffic from OpenFlow into a regular host-based network or a station network. You need to tie them together somehow. You can tie in very lame way, or you can tie with equipment region by adding a static routing mechanism inside into the OpenFlow network. To say, hey, if you don't know the route to forward within your OpenFlow network, then by default you need to gateway that is there. So the controller will do the R translation or whatnot, and then program the network automatically to make sure when there is no route available on the OpenFlow, we go to the traditional network, use the route. So this is a simple way of doing the OpenFlow bridging between OpenFlow and OpenFlow SDN and non-SDN network, but it's not widely used yet. The code is there, take a look at it, we can enhance it further. And we have host tracker. This is for tracking the host, VM, whatever that you can imagine. This is one of the codes. There's a discussion happening now on the architecture forum to merge two controllers. I don't know if you guys saw the discussion or not. We call it DE proposal, where they're trying to take the host tracker component from the satellite code base and trying to retrofit back here. Make it OSGI compliant, right, and put it back here. So let's see, this is happening now. So this will, you can see some change happening on this host tracker code base. Initially, it's going to track the host for you, right? And OpenFlow we have the OpenFlow. Look at the southbound, right? We have the northbound, we have the infrastructure components, and we have southbound. SAL is southbound. Right? SAL abstracts all the protocol specific ones to these modules. For example, topology manager, right? Topology manager will not worry about the OpenFlow or OSP, doesn't care. Right? All it worries about is the graph, the edge, and vertex. That's all it worries about. Whatever protocol specific is happening is handled only in the plugins that is on southbound. OpenFlow J is the bundle that is an open source component all available in Rails and author for this one. This is actually a southbound plugin. It's run under the SAM. It's not over the SAM. So we'll come and touch that. We'll discuss the southbound layer. Sorry? Yeah. There was no CLI in example CLI? Yes. No, example, you're not using it. No. This is the full OpenFlow project, and we modified it on the protocol layer. There's some bugs which we fixed it, and we put it here. But there's a discussion now saying, hey, let's contribute back to the main OpenFlow repository, which is Stanford, and then put from there. But there's a lot of discussion going on there. Whether you want to do that or have ODL as the base for the OpenFlow project, and all of us can add enhancements to OpenFlow, including the OpenFlow.c plugin. This is happening. We are not clear exactly on this, but at this point we have put in the code and insert into the right. So let me go quickly on this the rest of the modules. The Dijkstra algorithm, which we use young library to do the Dijkstra calculation between shortest path between two endpoints. You can also do constraint shortest path. Let's skip SAL for now. I'll come there. Security is a normal security layer. We have stats manager for pulling in the stats. Switch manager actually handles all the managing the switches. So when the switch comes up on OpenFlow or any other switch, called switch manager can be even router manager. Right? It doesn't matter. All it does is node management. If you look at the controller code across, we never look at OpenFlow as a concept, right? OpenFlow defined the switch ID as a long and the port as a short value. But you will not see anything about long or short or an ID value as represented in OpenFlow in the controller. Those are specific to the plugin OpenFlow plugin. The control assets, the entire code will work on two data structures called node and node connectors. You see it all along. Node is data structure that we use for representing a node, whether it could be an OpenFlow node or a 1CK node or a regular router is talking TCP or I2R, doesn't matter. We represent all of them as node data structure. So the switch manager is to manage nodes and node connectors. The new one coming along. So whenever you want to know what was available or a node available on the system, you call the switch manager and do a get switches. You get nodes, you get all the nodes. So this is the one making all the nodes existing at this given time. And topology manager, we all know is made in topology. Topology manager again is a component above SAL. When we go into the protocol plugins, I'll explain two more things on discovery. But topology manager is running above SAL. That means it again has no significance about OpenFlow or any protocol. It is above SAL. It talks only about graph, edges, and vertices. It's all good. Okay. So as you can imagine, look at the architecture now. The northbound layer depends on these bundles for their data operations, and these bundles have no idea about what southbound plugin we're talking about. Okay. So northbound and these bundles at this point are protocol and they don't know OpenFlow or MPK or whatever protocol, any protocol should ideally work because of this layer, SAL layer. Okay. What SAL layer provides is SAL layer is a very simple layer. Look at the SAL code. Even though there's a lot of discussion happening on SAL at this point, the current code is a very simple one. It's just a calculation layer. It gets what it provides is some plugin APIs, which these southbound protocols added to. Okay. Let me show the SAL code now. Look at SAL. I'm opening SAL. You see a lot of functions here. And again, the SAL API layer is not the implementation. See action, authorization, and various other things, discovery and program. So iDiscovery service as an example. So iDiscovery service is something which the SAL exposes, and this is something which the protocol plugin has to implement. When protocol implements, for example, OpenFlow, right? In OpenFlow, if you want to discover a topology, typically we are doing topology to discover topology in OpenFlow is to use LLDP mechanism. It's very common these days. The controller will inject LLDP, and through LLDP will learn the neighbors, and the neighbors learn, we found the topology. That's how the topology is built. Let's take a different example, right? Let's look at say OSPF, regular routing, right? So we have OSPF topology right in the network. You can pull it and form the topology on the protocol. So based on the southbound protocol, the topology layer can change. If you look at the code today, the OpenFlow southbound plugin, that's the topology management for us for OpenFlow. And in Cisco, we have 1PK. Right? 1PK is a plugin which does the topology discovery on the 1PK. Similarly, we can go to PSTEP, I2R, so on and so forth. When all of them to a common infrastructure called node and node connector. Okay? So above SAL, as you can see, above SAL, nobody knows about how the topology is being derived. All they care about from a topology standpoint is a graph. The reason we went to this approach is that when we began the whole control project, right? So, Overflow was important at the point, so we use Overflow as a base to see how it all works. But we started hearing a lot of requirements from the customers saying, "Hey, I cannot replace my entire network for to do Overflow because Overflow is separate. It's basically a business operation." So they want to introduce in the network by having Overflow Island. Also, the traditional routing protocol they have. That's the base. So in order to do that, do a controller for multiple protocols, we needed a layer like SAL, which provides the plugin approach with any plugin can come. If the plugin can talk the SAL language, it can come attach to it dynamically and inform the get all the services of the education services about the controller. That is the principle. Today we have open plugin, of course, right? And in Cisco we have developed the OpenDaylight plugin. Okay. Now, as you can see, few guys are developing the plugins now. So this is as and when there's a need to develop it. I know PCP is being developed now. I think also going to develop Open 1.3 also. So it's coming along, but as you can see, Northbound will go much faster than Southbound. But as and when there are a lot of people here in this consortium, right? There's a lot of need to. OSDB is one thing. There'll be a DOW will come and also. It's going to enhance. Right? There's no layering concept at all. At this point, we didn't even think about anything like that. When they layering it years, or it's just yeah, yes, yes, you're right. There is actually a problem. Look at today's code, right? The code is prevented, but the code is not very. If you want to merge the overlay and the topology, it's not very easy. You have a problem is there. You need to first identify is it an overlay happening, right? Even if you identify the overlay happening, you need to type that overlay into an underlay topology. It's not simple. So actually, the problem is known. We are looking at it, but it's not solution. It's not clean. Yeah. Yeah. So SAL, if you look at SAL, right, it has all these services defined here. It's all these are just interfaces. There's no actual code here. The actual code is the implementation. So data package service, flow programmer service, inventory, read service, and topology. All these are conduits that we come here. It is going to give when the request comes from the applications running on top of the SAL, it is going to translate them to the plugins. When the plugin gives a event back, it's going to give back to the application. That's all it's going to do. SAL is just a conduit. It's going to convert the layer where the protocol stops and the generalization begins. That's the SAL layer. If you look at all these, the APIs is clear, right? Here you see the I plugin in flow programmer service, and there's an I plugin out programmer service. So in means it's coming inside the SAL, it is going to the subcon layer. Out means it is coming from the subcon layer and going towards the application. So if that's a translation, so if you look at all these plugin services that you see in and out for translation. So SAL provides just that. Once SAL provides that, there you go. So protocol plugins OpenFlow. This is the OpenFlow southbound plugin. This one. If you open this one, you'll see that the core OpenFlow, everything right here, internal and everything. So now if you open this OpenFlow, you can see the data package service, flow programmer, everything defined here. Okay. And the implementation is right here. So if you look at the core internal. Controller Java is the base code. It's called OpenFlow controller, which is running under SAL. It's going to open the 650 port and it's going to manage your topology and everything. Once OpenFlow person is done, it's going to talk to SAL and then talk up. So all you want to, if you're developing a southbound protocol, okay, use OpenFlow as a mechanism to start with. So you know exactly how to develop it. So whatever is in SAL is the blueprint. Whatever is in OpenFlow today is the actual implementation of this protocol. And we have validated a lot of questions about, hey, does this validator even work? Because you are generalizing it too much. You can't have one SaaS can take care of all the open protocols. It's a valid concern. In fact, when we are developing the OpenFlow plugin for Cisco, we had some Java and some context. They're able to write a plugin OPK and able to make it work. But I cannot guarantee it's going to work the same way for all protocols. So we may have to enhance SAL for that. Such that when somebody wants to write a Southbound plugin, they have to see if this current SAL is capable to handle them or not. If not, they have to enhance SAL out. That's why it's open source.
So in this OpenFlow plugin, what we does, sell to the machine or the other OpenFlow say I need plugin to sell.
Oh, it's the same code, right? Again, it's a bundle. Right? See, if you look at now you're talking about from functional you are going to the runtime behavior. Runtime behavior is no different. Activator of Java. Whenever you ask a question about runtime behavior, you go to activator of Java. That's the starting point for you. Okay. From there you get all the answers to look for. So let me show you. So as you can see here, activator Java says that topology service Java class provides the iPlugin topology service and stream service. That means iPlugin, the topology OpenFlow server plugin, topology services class is going to get the events for whenever the SAL shows the event. So this is the binding, right? It's exactly discussed in the morning. So runtime behavior, don't worry about functionality, what functional module it is. It's all the same OSGA way of doing things. When it comes to functional level, it's different based on which layer you are. You are in a SAL layer or a plugin layer or open layer.
So for each service, there's an even plugin service.
Correct. Everything are plugin in and plugin out. In and out. Yes. Anyway. And also support correct. So we have another plugin. We have two plugins now. One PK plugin and OpenFlow. Yeah, we have one PK is not open source. One PK as the thing is not open source. Right? It's open source, if and when, accordingly you will be a if and asset fair. But sure, when I say not open source, I mean the decision for not open source is there. To that way. But there is the one PK may not. Yours is okay. Yeah, so it's not open source yet. But it's working. Sorry? Yeah, that's the thing. When somebody is developing a code, right? In the morning, I write code very practically. I don't write the code from scratch ever. I use the existing code and see how to develop the code. Right? So you want to develop any code, right? For example, you want to write an application. I would say look at the existing application in the code and try to reinvent. Don't reinvent it, just try to copy it and then try to do it first. If you're confident, then you can go and build your own. Similarly, if you're going to develop a new Southbound plugin, so you want to write an OBSDB, for example. Right? Don't try to understand it from scratch. This OpenFlow as a blueprint. look at how it's being done. Right? So look at SAL. You don't need OpenProduct. I mean, look at SAL APIs. You should be able to build it. But if you have a reference, it's easier for us to develop other protocols. So OpenFlow is the reference that we wrote. We gave it to the community. Anybody can look at the reference, look at the corresponding SAL services to see you're able to, you can develop your own plugin or not. If not, then you have to enhance SAL to accommodate your request. We have to do that. So far, we didn't see a need. So far, it's been smooth between OpenFlow and OpenPK so far. So we didn't enhance it yet. But this is a very practical approach. We don't know what is going to come. If something is going to come very different, we don't know. Correct. It's not pushed or whatever. See the plugin that we write, right? So OpenFlow protocol is down. The plugin, we are writing the plugin also. In the plugin, depending on the service, you have plugin in and plugin out. In the case of OpenFlow, say there's a link going down. Okay? You get a event saying what is down. And then you are supposed to form the topology discovery saying LTP is expired, and then you're supposed to push the topology up. Right? Say, let's take an example of MPT. You get a link going down here. Okay? But topology also will be happening for you. You don't calculate it. Okay? Okay? So what I'm saying is the implementation of how topology link is discovered or whatever, okay? It's up to the implementation of the plugin. But the service is plugin in and plugin out, always to worry about. So the states are modified, plugin out is the way to send it out. States could be a bandwidth, there's a QoS change or bandwidth change or whatever, latency modification. What is it?
So the main thing from this one is sort of spicy by
okay, today there's nothing like mapping between outbound and southbound. Today is nothing like that. But there's a discussion going on now for SAL V2 or model driven SAL. Okay? It's happening now. The SAL that you see here is a very simple SAL, right? Which is not model driven. It's based on APIs, the plugin in, plugin out, discovery out, and you're doing it all based on APIs. But the model driven SAL, if and when it comes, it's going to be based on models, Yang modeling or whatnot. When you have that, then you will have the outbound and southbound interface because Yang can generate automatically the outbound interface. Right? So there is a discussion. The architecture is that we have a Yang model on SAL. Yang model will be able to generate automatically the outbound APIs for resources, and for some resources which we cannot, which will have like components like the topology manager, post tracker, and whatnot. And then on top we'll have a more outbound APIs. So at this point, there's no outbound, southbound. So it's across the. If you look at this, look at SAL. Okay. Okay. The easiest one to do is look at activator. Okay. Look at activator. Look at the answer actually. I plug in topology service, right? I plug in out to topology service. I refresh internal provider. I plug in inventory service. Okay. So what you see here is a given module can have different class files, of course, right? Each class file can handle different services. That's what you're seeing here. A topology service handles these plugin topology service, plugin out topology service, right? That's right. Like so when you see interface, that means this provides a service. Out is dependent on the service. When somebody wants to update a topology out to the SAL, they'll use the out topology service and then push into it. The in is where the SAL will say, I want to push some event towards you. Okay? So look at the activator, Java. That's where you see all the dependencies in and out. It depends on what plugin you want to do. Yeah. It is work. It's not a. I won't lie to you that it's simple to do. it's not a lot at this point. Okay, you want to have a general idea, right? This is will give you an answer. This is the best way to look at it. See, you'll see a topology service, discovery service, programmer service. Not even see, data packet service, programmer service, inventory, read service, topology. And that's it. Not much. Oh, yes. Absolutely. Yes. It's a very good point. In fact, we already have the first plugin here. It's just nothing. Yeah, we have it here. But this is a good point. As an example, right? The data packet service. Okay? We implemented 1PK as a plugin, right? We didn't implement data packet service at all. Because not all plugin has to implement all services. Some plugin may not say you write a firewall, some outdated firewall which has a northbound API and REST API. Okay? You can write a southbound plugin using REST API. This is just only one thing, no problem. Happy, you can do exactly what it means. Yeah, stuff like this. Yeah. Yeah, put up, yeah, this one. This is not plugin. Put up against stuff. No, see, yes, you can of course look at that. But to me, look at OpenFlow as a base, so you know exactly how it works. When you develop this stuff plugin and then start developing it. So correct. Now it does. Yes. Correct. Correct. It is. Absolutely. And another point you brought up about the overlay and underlay topology discovery is another topic there. How do you merge overlay and underlay topology? At this point, right, above SAR, it's all topology standpoint, it's a graph, region, vectors. But it's not as simple as that, but it's that. That is stateless. Today, SAR V1 is stateless, but there is a discussion going on about SAR model driven SAR to be stateful, but SAR is stateless.
Okay, you also said that this merge parts. So
sorry, sir. Yes, there's one more thing I want to tell, right? Every bundle you see here, in OSGI, there's one more concept called fragments. The beauty of fragments is, without touching the base code, you can write your own bundle and attach as a fragment to the existing bundle. Okay? So, if you have requirement, okay, which you want to develop your code, and you want to enhance it and you don't want to contribute back to the community, say it's proprietary in nature, right? Then you can write a fragment and attach it to your computer and make it work for you. So some proprietary, some IPR related ones, which we have to do that. Again. As all of us, I'm not saying you can't do everything from it. Maybe you cannot. Some are very proprietary, which you cannot. Which you can use fragments and attach to them. So to answer the question, that's another way to answer the same question.
translated and delegated to topology manager or whatever set of applications above.
So there's one of them. So SAL may be stateless, but SAL has this stateless.
No.
So that's what I was trying to read.
SAL doesn't.
No. So it just basically.
So what is the database?
Translation.
SAL today has no database. It doesn't do anything, just do translation. It's very. It's individual modules, individual service. Topology manager has a database.
Oh.
Individual service. Yeah. SAL is just the Sal provides this abstraction layer. See, some discussions, right? I don't have visibility into any of those. I learned all this, so I can talk about it, right? What is going to come tomorrow, I just don't have visibility. But the discussion happening about model given stack, where the discussion about having a database hooked up to the model given stack to make it straightforward. Okay? As you said, right? They're saying instead of services having its own database, this has SAL as the main place to save all database and leave the services separate. It's two ways of looking at it. Yeah, that's a single part of failure point. Okay. SAL is no anything. It doesn't know about it. All it does is providing this service, right? It's called I plugin in and out. No, it's not true. It's not true, right? Again, based on your model. You have a model, right? Which is not a layer 2 topology, it's a layer 2 topology or something. You don't know. That's why tomorrow I can ask you.
Depends on the service manager or whatever the box the project manager is going to say, give me tips. Day 1, day 2, day 3, or whatever.
Yes.
And sell, ask the someone.
Today's SAL does not do any of this application specific stuff. It's all that above SAL. All it does is translation. Tomorrow's SAL, the cost of time, we don't know what's going to be.
So tomorrow, maybe every time back to the device, you may have a state stored so that you don't have to effectively that state model of device configuration by the ephemeral state is represented in SAL somewhere.
It's not a cache. So, it's above SAL. Yeah, but what in tomorrow's SAL, SAL V2 or tomorrow's SAL. I don't know what SAL is, right? I know tomorrow's SAL, okay? That SAL. Hey, that's why I'm saying, right? I don't want to be a critic of that. I want to play nice. I'm saying tomorrow's SAL, when it comes, let's see how it goes, right? I don't want to say anything about it. That's it. That's the current architecture. We want to maintain that. But no, of course, it's beyond me. It's open source. So. Even today, again, there is a lot of videos here. So there is a lot of videos. I mean, not about 1PK and everything, right? The reason I'm saying that is, no. This is okay. Now I'm saying is, when you say ask questions, right? I can answer you say it's possible, but I can give you a better answer by saying, hey, it's done already. The way it is done is by saying, hey, you can look at the setting of properties in SAL, SAL properties. Use properties effectively to communicate various mechanisms. So as I said, right, SAL is a very transition, it doesn't do anything much. So the Southbound plugin has various tools to communicate a lot of things to the upper layer or tools. Use those tools, include layer topology, layer topology, overlay topology, whatever, right? All such open given today's code. You may not see in OpenFlow because it's not there, but SAL that provides all functionality. Correct. SAL doesn't do anything of this. But SAL provides this mechanism. For example, I'll show you one small thing. If you look at SAL code, so I don't know any documentation, I can just show the code. There you go, okay? You see a lot of tags here, right? Each these are all data structure representing what not. Okay? Not everything need be represented by OpenFlow, but many folks can make it. For example, let's just take an example, right? Peer bandwidth. Right? This is an extends bandwidth. Okay, when you open bandwidth, it extends property. So property is an abstract class, so it doesn't do anything. But Cal provides the ability to transmit the properties from southbound to the upper layers. Right? So now you can imagine, hey, if you can send layer properties, layer 4 properties, overlay properties, you can do that. So Sal provides a conduit. It provides you an abstract class called property. Using that, you can do a lot more stuff.
Yeah, some other. And so this exposes certain attributes of
Right.
the feature, and other one is EEC. So there is an intersection of E and C. So if the cell, when it has this kind of function, band, it will have A, B, C, D, and all exposed as properties, and depending on which device, which interface you're accessing. So
Absolutely.
So that yes. Will be available or not available.
Correct. Absolutely. Yes. Look at this. Look at Node. That's why I was explaining about Node. So let's go to the Node. All this code wins, right? The Node code is not well written, just minded, but it expresses what I want to explain here.
Which node?
It's Node. It's Node. That's it. There's no. This is a Sal node. Okay. Sal node. There you go. Sal code, right? Sal code. It's an abstract. It's a data structure. It doesn't represent anything. It represents that there is a node. Okay? There is node ID. So when it says it's not written properly, this is what it is. I don't like to see these strings also be part of Sal. Yeah, I don't like it. So, I don't like the hard coding there. Explaining. Even though it's not hard coding, it's string there. Okay? I don't like the string also. It should be dynamic in nature. So actually we didn't do it. We actually did it here. But we didn't get time to clean it up. We'll clean it up. You can clean it up. Yeah. So register ID type is what we should use ID. You should use this type value pair, and register the strings and make it happen. But this is we did it long time back, and I hate this. Yeah, as you can see here, we see OpenFlow, OPK, all these things here, right? Type here. You can actually call this register ID type and register dynamically whichever type you want. So node is the data structure, which represents an abstract way of looking at any protocol, any device. So a same device can connect to the controller via two protocols, OpenFlow and OPK. Even though the same is connected to it, when the child queries this node will say, one node, two nodes now, right? One node will say, I cannot do database services. Other node will say, yes, I can do it. Because it's so protocol nature. And above the stack, these four guys do not know whether it's the same device or different device. It is two different nodes. That's what I'm saying, right? There we can write proprietary bundles which can bring them together and unify the services.
ID, there is always something you need to be able to.
If you can find one, please. Great. No thing. You want to go back and find this from
There are always some. Maybe within your network.
Please do it for me. Again, we're requesting for the same thing. Please do it for me. I'll be happy.
Right now, we have two different interfaces. They will appear.
Yes. So yeah. That's all.
Or it could be a UUID.
Could be UUID, but all protocols must adhere to the UUID. The problem is this one, right? OpenFlow says, hey, I have a UUID. Okay? I go to BGPLS. What UUID? You just want to solve the problem. I'm happy. I have some problem already delegated now.
So, I mean, give it to me. No. Yeah, that's good.
See, look at give me an example. OpenFlow. Unique identity for OpenFlow is which I long. Okay? There's only for OpenFlow. Nobody else care about. So there are very proprietary ways to put them together. It's happening now. I'm not saying it's not happening. Okay? There's no clean way. This engine is new for all of us. Okay? And this is a new problem. Hey, I have multiple protocols connected to the controller. Both are same. I don't even know if I'm 100%. It's all new, right? Different will be based down the line. But, yeah, this will be
My network, I make sure for the string.
it's certainly if an object, if a customer is writing their own app, okay, and if they know exactly what it is, of course they can write whatever app they want to. But how many customers are going to write their own app? Right? It's going to be a generic app. Customers are going to buy from whoever. Right? How can you write a generic app based on somebody's network? Right? It's not a complicated problem. Yes, you can solve. You can solve one instance, two instances. But think about it. Overall picture, it's a hard problem. Correct. Yes. So now with more connectors. That's not get it. It's right here. It's all right here. Actions. Hey, by the way, it's 3:50. You want to take a break? I'm just talking nonsense. No break needed? Okay. Okay, sure. Yeah. Yeah. So actions is there, basic ones, right? Bandwidth, advertising, there are properties. There are properties, yeah. All these are properties, okay? Let's see. Host. Edge is the base layer. Edge is the link. Edge, as you can see, tail connector and head connector. Yes, but from topology standpoint, without an edge, you cannot cover topology. Yeah, but edge is the base. Even though you use word connector, edge is the base. Yeah. Deep-edging is node-to-node connector. Host. Let's see. Path, again, you say is not base. Okay, fine. Property is base. That's fine. All other things, mostly these things are properties. Yeah, all there. That's it. That's it. Not much. It's not. Once you look at the code, actually, there's a problem here. Okay? Hey, there's one more thing. Container flow is also basic, I think. Yeah, this is a basic one. Container flow. And match. Match was a basic. Okay, container flow is flow. Okay, you don't worry about container naming is messed up. Match is also basic. Yeah. One. Yeah. Yes. Yes. Because you developed it, right? That's what I say. No, it's 1.5 years. Yeah. From the date we start coding to close to 1.5 years. We don't know exact date ever, right? I would say close, give and take 1.5 years to 2 years. Why is that important? Yes, who is that? If it's important, I'll definitely answer. It's not important. Overflow plugin, look at it, right? We use OpenFlow J as a protocol mechanism. Plugin is simple. Once you know the concept, right? Plugin is simple. So yeah, I gave it. I mean, I don't know what.
So all of these class are the superset. That means you have even having those plugin does support.
There's one more thing I want to tell you. You're right. These things is so many things, right? Again, to me, it's a mistake to have so many fixed classes to be part of. Okay? So I'm working on this called custom properties. Okay? Which will, I think we will commit soon. Where you not see properties like this. They're all dynamic user-defined properties with various attributes to that. Once you see that it's all collapsed to only one generic property, then it will be dynamically handled anyway. Interesting. I understand the question.
The question is that let's say out of the feature how do you know the
First of all, how do you know these two are same nodes? Oh, sure, no, sure.
But you have to map it properly so that both the API, you have supposing that A, B, C, D, you can get any of these properties, right?
No, right? Expose only 3 will expose only.
You will expose all 4, right? A, B, C, D.
Why?
And
the node doesn't know what the problem is. Right? OpenFlow, you cannot go and ask something like PDB. It doesn't know. You cannot expose that, of course. Right? So, I'm missing the point.
What I'm saying is that for a given feature, like that's a feature, or maybe this, or like a already state for something. So, overflow implement boundary still lay in the future.
Right. There's no nothing like OpenFlow, but yeah.
Yeah, but right. So that's the OSDB, you don't have boundaries. You don't have cheat or something. So the thing is, because of an outbound API, they have bandwidth
and these custom properties, right? Do not dedicate your normal APIs for these properties. Normal APIs, as you can look at it, right? They're all high-level service levels. We're talking about properties.
Service level will allow at some point to mine.
Yeah, you get the properties, right?
Yeah.
It's for switch manager, okay? Switch manager is the API call.
Let's give it an example. Even though you may say to expose the link property, but you may say, no fun API say, I want to find out OPAS cheat, something like that.
Correct.
Or OPAS delay. So
you cannot find it. If the property is not available by some protocols which you type in, you cannot find it. No magic.
But my point is, you find the patch or whatever, which you the patch support.
Undo what?
Support to say, I mean, I'm letting go of that.
Again, we're talking about application. We're talking about application which want to tie in the topology information and the property information, and somehow want to merge them and find out the best jitter path. And they're asking, what is this one between doesn't have jitter path? Application, handle the way you want to handle. I can expose whatever exposed by the
That's the thing is you have to expose that, right?
Of course,
expose that. Okay. But the point is that that's not in place. Or expose that if someone doesn't support that.
You don't expose it, right?
My question was that each element.
You allow me to take a break now, and sir, we can discuss what this is. I don't want to hold up everybody. All right. So guys, after this one, right, shall we write some code? Okay. Okay. Great. Yeah. No. Oh no. Container. Container. Container.
So tenant is basically the container whatever
Yes. Continue. Thank you. Next question. Yeah, let's go ahead. I'll show you what is happening with. Right now, it's now it's just one, but currently that can turn out.
My
Yeah,
yeah, I think that's the thing of the sale itself. Sale so if you want to find that
yeah. Yeah. Value. What is more? Property was property. More not sure.
whatever tag they have, right? So let's say tag one, tag two, here you will have a tag on for device, tag, and then so for device one it is tag one, tag two, tag this is the sale. You will have some sort of at the property level, generic property.
This is for doing it.
No,
Come on, not a good
tag one, tag two, tag three. This one and this one. Doesn't know that AR one and AR two, one and AR two together.
Oh. All right. Action property. Not property cover. So this is the answer provided. But the thing is, all the dates under the multiple so it's not part of taking multiple property. Not a handle. It's applicant property. Yeah. What the word I know one year.
So I'm going to have, you're saying that right now you have all these attributes. Are you going to have these and custom, or are you going to get rid of this and you're going to have everything custom?
It's already there.
It's already in the core.
It's already there.
That's the common stuff.
I don't want to have it. I don't want to have it.
So in that case, everything will become custom property. If it becomes custom property, what is that? What is this? Everything is application dependent. What is the anything to the site? So what does that do with that?
That's what it is.
So which model driven artist stuff? Automatic. No, this where we don't get no hardcode stuff. Yeah, because you will define a model and you will plug in. These plugins will actually plug into a model dynamically, and in my case, outbound interfaces are also going to sort of auto-generated, and applications sort of registered to those APIs or
those APIs automatically. So if there is a new attribute in the device, then you have to also represent that in the model somehow. And if it is in the model, potentially if it's in the model, then it will be populated in the model, and the northbound API will automatically be generated. And in the other device, if that protocol doesn't support, let's say, then that model is not going to be, that attribute is not going to be populated because that protocol doesn't support it. So in that case, somehow we solve the problem. We should solve it. Using two different protocols, let's say somehow solve. So two different interfaces into a single device. They would expose different attributes. The model will basically multiply.
That intelligence where we drive that intelligence where we design that application.
I've already find a way to overcome all they have, but it's not a simple problem to solve. How do you do something? It's no way to do for it. It's not how to say the problem. Product yeah. Just let it map it there. You map it with it's still copy of it. No issue. You think that works. Not only the
because even then it could just be model doesn't happen. Model is just a driver. Because anytime a northbound API is call is corresponding from API. And even then it could be stateless. Even then I'm sorry. No, I'm saying even in future style version 2. Even then it doesn't have that. That's all I'm saying.
Please talk beyond that.
There's
No. It's very important, right? To understand dynamics. It's open data. Everybody gets it. Just keep contact with it. It's so many people. Good is jumping, they are taking the point, you want to take this and the other, even if it's down. You got to have to get it. Up to them. That's taking their thoughts. Yeah, I'm working with all you want to do this case there. Because then you take a big down. One model. This one data here. These number APIs, so they have single point for them all. That's what we're going to do. That's the one you decide. So part of the
good. All right. Yeah, thanks for the background.
yeah, good. Understand a lot of dynamics.